Life is like chemistry. There is a lot of reactions. If you want to make a perfect solution, then it's necessary to mix the right chemicals in the right quantities. Otherwise, you will blame your fortune. I'm Roy. Hello class. Today's lesson is about alkyl halides. We are going to talk about definition, classification, nomenclature, isomerism, and physical properties of alkyl halides. But before we continue, I want to remind you about the previous topics. I call your kind attention because I want you to retain every single detail of the lesson. Previously, we have talked about the introduction to organic chemistry, where we defined the organic chemistry as a branch of chemistry that deals with compounds of carbon, with very few exceptions like metal carbides, metal hydrogen carbonates, metal carbonates, oxide of carbons, and a few others. We have also talked about the homologal series, which is defined as a series of organic compounds which have the same functional groups but different in repeating unity, CH2, called methylene. We also talked about the functional group, which is an atom or group of atoms responsible for the characteristic reactions of a particular compound. We also talked about the hydrocarbons. Hydrocarbons, they are organic compounds which are composed by carbon and hydrogen atoms only. In these hydrocarbons, we can list alkanes, alkenes, and alkynes. We define the alkanes as saturated hydrocarbons which contain hydrogen and carbon atoms linked by single bonds only. We also talked about the alkenes, which are unsaturated hydrocarbons which are composed by carbon and hydrogen atoms but having at least one double bond. And we talked about alkynes, which are unsaturated hydrocarbons which contain at least one triple bond. You may be wondering, what is the difference between alkenes and alkynes? The only main difference in them is that alkynes are more unsaturated than alkenes because they are lacking more hydrogen atoms than the alkenes are lacking. In other words, in alkynes we have a triple bond between carbon atoms, while in alkenes we have double bond between carbon atoms. Coming back to alkyl halides, alkyl halides is a class of organic compounds resulting from a simple replacement of one, two, or more hydrogen atoms in the structure of hydrocarbons. Their general formula is Rx, where R refers to alkyl group and X refers to halogens as well as fluorine, chlorine, bromine, and iodine. For monosubstituted halogenoalkanes, the general formula is CnH2n plus 1x. Trying to explain this, alkyl halides, they are derivatives of hydrocarbons. It means that these may be saturated or unsaturated depending on the parent hydrocarbon. If the parent hydrocarbon was saturated, the alkyl halides will be saturated. If the parent hydrocarbon was unsaturated, these ones will also be unsaturated. Looking at Rx, this is an abbreviated way of writing alkyl halide, where R represents an alkyl. The alkyl groups, as you remember, it is an alkyl which has lost hydrogen atom. For example, if it was methane and it loses one hydrogen atom, it will become CH3. So this one will be called methyl. If it was ethane and it loses one hydrogen, it will become C2H5. Again, if it had 3 carbons and it loses one hydrogen, it will be C3H7. You can try more. The halogen, represented by X, is the one we have said that it may be fluorine, chlorine, bromine, and iodine. So if we combine alkyl and halide, they will form alkyl halides. This is where the name alkyl halide comes from. For monosubstituted halogenoalkanes, you can ask yourself what is monosubstituted and what if it is not monosubstituted. A monosubstituted means that only one hydrogen atom has been replaced by only one halogen atom, which means that if more than one hydrogen atom is replaced by more than one halogen, this will not be monosubstituted, it will be polysubstituted. So this formula is working only with the monosubstituted, where N represents the number of carbons in the chain. This N can be 1, 2, 3, 4, and so on, depending on the carbon chain you have. If N is equal to 1, we can have, for example, N equal to 1. The formula of alkyl halide will be CH3X. You can calculate. But if N is equal to 2, the molecule will be C2H5X. And then if you understood it, you can try it when N is equal to 3. What will be the formula of alkyl halide? Classification of alkyl halides. They can be classified into primary, secondary, and tertiary alkyl halides, as represented below. This is a primary alkyl halide, secondary alkyl halide, and tertiary alkyl halide. But to help you understand this, let us go back to the primary carbon, secondary carbon, and tertiary carbon. As you remember, a primary carbon is a carbon which is attached to only one other carbon. A secondary carbon, it is a carbon which is attached to other two carbons. While a tertiary carbon is a carbon which is attached to 3 other carbons. So after seeing this, we can now define primary, secondary, and tertiary alkyl halide. Using these examples, a primary alkyl halide, it is an alkyl halide in which a halogen is attached to a primary carbon. A secondary alkyl halide is an alkyl halide in which a halogen is attached to the secondary carbon, while a tertiary alkyl halide, it is an alkyl halide in which a halogen is attached to the tertiary carbon. So after, we can conclude that the alkyl halides are classified into 3 main classes: primary alkyl halide, secondary alkyl halide, and tertiary alkyl halide, where a primary alkyl halide is an alkyl halide in which a halogen is attached to the primary carbon. A secondary alkyl halide, the halogen is attached to the secondary carbon. And the tertiary alkyl halide, the halogen is attached to the tertiary carbon. Other classification of alkyl halides. If the halogen atom or atoms are bound directly on the benzene ring, the alkyl halide is called aromatic halide or allyl halide. This can be explained when we draw a benzene ring like this. If the halogen is attached directly to one of the carbon of the ring, this one will be called aromatic halide. But on the other hand, if we have a benzene ring like this, and the halogen is not directly attached to the benzene ring, this is not an aromatic halide. As you can see, there is a difference. On the first example, the halogen is directly attached to the benzene ring, while in the second example, the halogen is attached to the CH2 group, where the CH group is the one which is attached to the benzene ring. It means that the halogen is not directly attached to the benzene ring. This is an alkyl halide, but which is not aromatic, while that one was an alkyl halide which is aromatic.